Now we are discuss on the geological structure. Okay, the geological structure, we call that, we name it based on the shape of the formation, how the shape looks like. So we will discuss fault, joint, and fold. Okay, so normally in the sediment rock, the original of our sediment rock is in the flat condition like this. So this is the flat sediment rocks. So just imagine how it looks like. This is undisturbed sedimentary rock. So what happened is our faults. This we discuss on fault. Fault is a fracture that has displacement. This is the important. Displacement is the term. When we discuss about fault, is about displacement. And then the adjacent rock will adjacent rock mass will slip past one another in response of tensional, compression, or shear. This fault creates zone of weak and less stable ground, and if we have sudden movement, so that will cause earthquake. So this is example of fault. So this is a San Andreas fault. You can see this valley here. So this is how in the bird view of the fault line, this large scale, very large scale, a few and it reach 100 kilometer for San Andreas fault. But this is another fault. The scale is different, so you can see this one. This is line, this line. So you can see this is a sediment rock in flat land. You can see this bedding, this rock layer, and this rock layer displaced, displaced, little bit displaced. So mean that this is what happened is this rock block is moved down. So this one moved down. Okay. If we do not see any movement, then we call it as another types of structure. We call it joint. So this is very clear. See, this is another line. Weak plane. This is weak plane because this line is experience movement. So you can see this bedding plane, and this plane should be continuous, but now is drops a bit here. So we call that this a normal fault. It's drop down. Okay. This maybe this because of this tensional of this body, so this one drop down. This body drop down. Tensional. Okay, so this is another fault line. Okay, you can see here this line. Okay, you can see the bedding plane here. And this place not continuous. See this block, maybe here or here. Maybe not very clear. So in this fault category is subjected on the type of movement. So we call it normal fault. We have a reverse fault, we have lateral and oblique slip fault. So if we have reverse fault, is about compression force. Normal fault is because of the tensional force. If we have lateral fault, because of this shear force. This is how this rock mass looks like. If we have tensional, so this block will be going up. Okay, it's against the gravity. For example, here this block is moving down because of, see, you can see this crack here. So mean that this block is moved down because of this tensional force. So for lateral, we have movement in lateral form. Okay. For oblique slip fault is combination of this slide, this fault and normal fault or reverse fault. So this is a normal faults we discussed. Important is this is tension or an extension. Tension force. This is going down here. Okay. Reverse fault we have shortening, which is a compression force. So the other side is moving up. Okay. And then we have lateral fault is subject to horizontal movement. So you can see here. Okay. And then if oblique slip fault, we have a combination of these lateral, whether upward, downward movement, or whether it's normal or reverse fault. Okay, we have discussed on the research on fault. Now we are discussing on rock structure, geological structure on joint. Okay, geological structure. Sometimes I call it rock structure. Okay, rock fracture. If we have a fracture on rock, but we cannot see, we cannot observe any movement, any sign of movement. Not we can see movement, but the sign of movement. Similar like the fault is sign of movement. Okay. So if we don't see any sign of movement, so meaning that this is called that as a joint. So this formed by tectonic stress resulted a systematic fracture. Yeah? Term of systematic fracture. Yeah? For joint normally is systematic. That's why in lab 4 we are trying to obtain the system of the fracture based on 120 data of discontinuity. So can found any type of rock. So this is a key point. Joint we can observe in any kind of rocks similar to fault. That's fine. But bedding clean only special in sedimentary rock. Metamorphic foliation only metamorphic rock. But joint you can found in any type of rock, either sediment, metamorph, or igneous. Term discontinuity in rock mass adopt in any mechanical break of joint fault. Sometimes we call it discontinuity. Which is discuss any mechanical break, which is has a tensional force almost zero. This is definition of discontinuity in rock. So as I said, systematic. The keyword is systematic fracture. So looks on this example of outcrop. This outcrop you can see this systematic fracture like a blocks in very nice perpendicularly each other. So you can see, but we have one joint here. Yeah. In this is spacing. Each joint we call it spacing. Spacing of the joint. So we have another joint here. So you can see two set of discontinuity. Two set of discontinuity. Here is another joint set. You can see the pattern. We have a pattern like this. Yeah, like this joint set. This is spacing between this one and the stop here. So we have another joint here. Stop here. So this is persistent. It is quite long here. They have similar deep direction and almost similar deep angle. So we call that set. So we have one set here. So we have another set here. So almost parallel, almost direction. So the second set, and we have another set here. Okay, you can see here. Some is quite long, some is short. The persistent, this independently for the persistent. This another set. We have three sets of discontinuity here. So that is the joint. So in this is in granitic rock. So we not see any movement, any sign of movement in this rock. So we call that as a joint. So this similar like this, we have a joint similar set. You can see similar directions. Also here quite the system is quite tight, close spacing in the fracture. See, very close, very. You can see this is a key. This is Mercedes, yeah. So you can see how small the fracture. So this is systematic. And joint will be break in systematic way. Another geological structure we call it fold, which is main fold as band layer. Band layer due to the collision of the tectonic. If we have upward fold, we call it anticline. Downward fold, we call it syncline. This is we are discussing fold. We discuss in lab 2 as well as for lab 2. So we have syncline, we have anticline. This is anticline. This is syncline. We have axis in the middle. So to look on that, this is example. We have a syncline here. Yeah, maybe we can see this is upward here. See, this is anticline. So this is the scale. This is the scale. See, this is in Malaysia, and this is in Jengke Pahang. Okay, this one is at overseas. Okay. Okay, this is another beautiful crop, full anticline, syncline. Okay, you can see the maybe fault line here. Also another here. This is anticline. This is big, huge size of anticline. This is quite small, thick, very tight anticline and syncline here. So this is it's sedimentary rocks. So see the syncline on top here, we have anticline here, syncline here. The shape is very depend on the like this overturning like this. See, originally is like this, but now turn to like this. So you just imagine the force, the direction of force is keep changing, and then shape our structure like this, similar like this, the bending like this. So means here is in that this is ductile. The behavior fold is behavior shows behavior, ductile behavior. For joint is brittle, and yeah, for fracture, for fault also brittle. So for joint for fold normally is show a ductile behavior, the formation like this. Very is located very deep. The pressure, the temperature is high, very deep, and then also maybe the speed or the rate of the vector is another is rate, slow rate of shear, slow rate of the force or stress. So we have a few categories. We call that monocline, anticline, and syncline, and overturn. So we call it monocline, which is have on the one pole, or call that is gentle dipping band. Okay, one side is bending. This both side is bending upwards, called anticline. So syncline is downwards. So overturn mean the axis is in the same directions, in similar direction. The deep direction is in this way, so mean that is overturn. So stop here. Continue.